Hi students, welcome to Go Vidya. ఈ రోజు మనం బేసిక్ సైన్స్ అండ్ ఇంజనీరింగ్ డ్రాయింగ్ నుండి బేసిక్స్ ఎలక్ట్రిసిటీ నుండి టాప్ 25 క్వశ్చన్స్ డిస్కస్ చేద్దాం. మనకి బేసిక్ ఎలక్ట్రిసిటీ నుండి 8 to 9 మార్క్స్ అనేది రావడం జరుగుతుంది. ఓకే, ఏ కరెంట్ ఆఫ్ 2 amperes flows through 24 volts car headlight lamp for 5 minutes. How much energy transfer during this time? Okay, we are asking energy. Energy is equal to power into time. Power into time. Okay, power is equal to voltage into current. Voltage into current into time. Okay, voltage is given. Voltage is 24 volts and current is 2 amperes and time is 5 minutes. 5 minutes we have to convert into seconds. 5 into 60. 5 into 60. Okay, 24 into 2 48. 5 into 60 300. 48 into 300 is equal to 14400 joules. Okay, from the options, option A is the correct answer. Okay, next question. The electrical energy used during a month can be expressed in terms of units. Okay, 1 unit means, okay, మనం మంత్లీ కన్జ్యూమ్ చేసుకునే ఎనర్జీని మనం యూనిట్స్లో కొలుస్తాము. ఓకే, యూనిట్స్ కెన్ బి యూనిట్స్ ఈజ్ ద మెజర్మెంట్ ఆఫ్ ఎలక్ట్రికల్ ఎనర్జీ. ఓకే, 1 unit is equal to 1 kilowatt hour. 1 kilowatt hour. Okay, యూనిట్ అనేది 1 kilowatt hour. Okay, from the options, option B is the correct answer. Okay, next question. 1 kilowatt hour is equal to how many joules? Okay, 1 kilowatt hour. Okay, 1 kilowatt hour. Okay, 1 kilowatt hour means 1000 watts. 1000 watts and 1 hour means 3600 seconds. 3600 seconds. Okay, 1000 into 3600 is equal to 3600,000. Okay, watt second. Okay, watt second is the unit of joule. Okay, watt second మనం జౌల్ కూడా అనొచ్చు. ఓకే, మనం దీన్ని 3.6 into 10 power 5 అని కూడా రాసుకోవచ్చు. 10 power 5 joules. 1 kilowatt hour is equal to 1 kilowatt hour is equal to 3.6 into 10 power 5 joules. From the options, option B is the correct answer. Okay, next question. 1 ampere is equal to, okay, 1 ampere, we know that current is equal to charge by time. Current is equal to charge by time. Okay, current units are amperes and charge units are coulombs and time units are seconds. Okay, 1 ampere is equal to 1 coulomb per 1 second. From the options, coulomb by second, option D is the correct answer. Okay, next question. An electric iron having resistance of 20 ohms and takes current of 5 amperes. Heat flow in 30 seconds is heat flow means heat is equal to I square RT. Okay, what is the value of I is equal to 5 amperes. 5 square into R is 20 ohms and time is 30 seconds. Okay, 25 into 600. Okay, it will become 25 into 60 150. into 00. Okay, we can also write 1.5 into 10 power 4 joules. Okay, from the options, option A is the correct answer. Okay, next question. Find the potential difference in volts across a resistance of 2.5 kilo ohm through which 2 milliamperes is flowing. Okay, one resistor is given. The value of resistor is 2.5 kilo ohms. 2.5 kilo ohms through which 2 milliamperes current is flowing. 2 milliampere current is flowing. We have to find potential difference across this resistor. Okay, we know Ohm's law. Ohm's law is equal to voltage is equal to current into resistor. V is equal to IR. V is equal to IR. Okay, we have to find voltage. The value of I is 2 milliamperes. 2 milliamperes means 2 into 10 power minus 3, and the resistance value is 2.5 kilo ohms. 2.5 into 10 power plus 3. Okay, 10 power plus 3 and 10 power minus 3 will cancel. 2 into 2.5, 5. V is equal to 5 volts. 5 volts. Okay, from the options, option D is the correct answer. Okay, next question. The resistance of the metal rod depends on all of the following except. The resistance అనేది ఏ పారామీటర్స్ మీద డిపెండ్ అవుతుంది, ఏ పారామీటర్స్ మీద డిపెండ్ కాదు అనేది we will discuss. R is equal to rho L by A. Okay, R is directly proportional to resistivity. Resistance అనేది resistivity మీద డిపెండ్ అవుతుంది, and resistance is directly proportional to length, and resistance is inversely proportional to area. Okay, and resistance అనేది టెంపరేచర్ మీద కూడా డిపెండ్ అవుతుంది. ఓకే, మరి టెంపరేచర్ మీద డిపెండ్ అవుతుంది. ఓకే, R1 is equal to R0 into 1 plus alpha T. T is the temperature. Resistance అనేది టెంపరేచర్ మీద డిపెండ్ అవుతుంది, రెసిస్టివిటీ మీద డిపెండ్ అవుతుంది, లెంత్ మీద అండ్ ఏరియా మీద డిపెండ్ అవుతుంది. ఓకే, రెసిస్టెన్స్ మీద డిపెండ్ అవుతుంది, అండ్ లెంత్ మీద డిపెండ్ అవుతుంది, టెంపరేచర్ మీద డిపెండ్ అవుతుంది, బట్ it will not depend on density. Okay, option A is the correct answer. Next question. Two resistors of R ohm and 15 ohm are connected in parallel. The effective resistance is 12 ohms. Find the R. Okay, two resistors. Okay, one is R ohms and one more is 15 ohms. The resultant resistance is 12 ohms. Okay, we know that 1 by R equivalent is equal to 1 by R1 plus 1 by R2. When two resistors are connected in parallel, the resultant resistance is equal to 1 by R equivalent is equal to 1 by R1 plus 1 by R2. R equivalent is given. R equivalent is equal to 12. 1 by 12 is equal to 1 by R plus 1 by 15. Okay, from this we will get 1 by R is equal to 1 by 12 minus 1 by 15. Okay, 15 minus 12 by 12 into 15. Okay, 12 minus 15, 3. 3 by 12 into 15. 3 1 ja, 3 5 ja. Okay, 12 into 5, 60. 1 by R equivalent is equal to 1 by R equal to 1 by 60. From here we will get R equal to 60 ohms. Okay, from the options, option B is the correct answer. Next question. Two resistors of 1 ohm and 2 ohm are connected in series. The effective resistance is, two resistors are connected in series. One is 1 ohm and second resistor is 2 ohms. The resultant resistance is, okay, R equivalent is equal to R1 plus R2. Okay, when they are in series, R equivalent is equal to R1 plus R2. When they are in parallel, 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Okay, 1 by R equivalent is equal to, one resistor is 1 and one more is 2 is equal to 3 ohms. From the options, option B is the correct answer. Okay, next question. A wire is stretched 4 times of its original length. The resistance of stretched wire will be dash times of its original resistance. Okay, the length of the wire is L, having resistance of R. Okay, same wire is stretched, mana sagadisham. Okay, same wire is stretched 4 times of its length, 4 times of its length. Okay, 4L. What is the resistance? Okay, okay, I will give one formula. R nu is equal to n square into R old. మనకి n అనేది స్ట్రెచింగ్, హౌ మెనీ టైమ్స్ స్ట్రెచ్ చేసాం అనేది n ఇండికేట్ చేస్తుంది. హియర్ n ఈజ్ ఈక్వల్ టు 4 టైమ్స్ స్ట్రెచ్ చేసాం, 4 టైమ్స్ ఆఫ్ ఒరిజినల్ లెంత్. ఆర్ న్యూ ఈజ్ ఈక్వల్ టు n స్క్వేర్ 4 స్క్వేర్ ఇంటూ ఆర్ old. Okay, R new is equal to 16 into R old. 4 square is equal to 16 into R old. Okay, okay, the new resistance is 16 times of the old resistance. From the options, option C is the correct answer. Okay, next question. The current rating of 5 kilo ohm and 1/2 watt resistor is, okay, we know that power is equal to, okay, current rating we have to find I square R. Okay, power is given, power is equal to 1/2 and we have to find I square R. Resistance is 5 kilo ohm, 5 into 1000. Okay, 5 kilo ohm. Okay, I square is equal to 1/5000, 5000 into 2 into 5000. Okay, is equal to 1/10,000. Okay, I is equal to square root of 1/10,000 is equal to 1/1000, 1/100. 10,000 square root is equal to 1/100. 1/100 is equal to 0.01. 0.01. Okay, 0.01 amperes. Okay, from the options, option D is the correct answer. Okay, next question. For the circuit shown, find I. Where is I? I ekkada undi? Here. I. We have to find I. Okay, we have to apply KCL. What is KCL? KCL is equal to incoming current is equal to outgoing currents. Okay, KCL, we have to apply KCL here. Okay, here 2 amperes is coming and here 1 ampere is coming, here 3 amperes. 2 plus 1 plus 3, 2 plus 1 plus 3 is equal to 6. Same 6 amperes will leave from here. Okay, here 6 amperes is entering and here 5 amperes is entering. Okay, 5 plus 6, 11. From 11, 3 amperes is leaving from here. 11 minus 3, 9. 11 minus 3, 8. 8 amperes will leave from here. Okay, 8 amperes. From 8 amperes, here 2 amperes is leaving, remaining 6 amperes will leave from here. I is equal to 6 amperes. Okay, just apply KCL. Okay, from the options, option C is the correct answer. Okay, next question. The potential applied across 2 farad capacitor is 10 volts. The energy stored in it will be, okay, we know energy is equal to 1/2 CV square for capacitor, for inductor E is equal to 1/2 Li square for inductor. Okay, here capacitor value is given and also voltage value is given. Okay, we have to substitute here. 1/2 C value is 2 farads and V value is 10 square. Okay, 2 will cancel, 10 square is equal to 100 joules. Okay, energy is 100 joules. From the options, option B is the correct answer. Okay, next question. 4 cells of EMF E, 4 cells having EMF E are connected in series. The effective EMF of combination will be, okay, 4 cells, each cell is having EMF of E, they are connected in series. See, one cell, one more, E, each cell is having E, they are connected in series. What is resultant EMF? Okay, in series the EMF will be added, in parallel the voltage across each branch is same. E equivalent is equal to E plus E plus E plus E is equal to 4E. Okay, from the options, option B is the correct answer. Okay, if 4 cells are connected in parallel, okay, ఒకవేళ ఇవే 4 cells మనకి ప్యారల్ కనెక్ట్ చేసామనుకోండి, మనకి ఇక్కడ ఈక్వలెంట్ వోల్టేజ్ కూడా ఈనే ఉంటుంది. ఓకే, ఒకవేళ సిరీస్లో కనెక్ట్ చేస్తే మనకి అన్ని ఈఎంఎఫ్ని యాడ్ చేయాలి. ఓకే, నెక్స్ట్, వాట్ ఈస్ ద టోటల్ కెపాసిటెన్స్ ఆఫ్ ది గివెన్ సర్క్యూట్? ఓకే, హియర్ 8 microfarad and here 8 microfarad are connected in parallel. Okay, if two capacitors are C1 and C2 connected in parallel, C equivalent is equal to C1 plus C2. Okay, here 8 microfarad and 8 microfarad are connected in parallel. C equivalent is equal to C1 plus C2. 8 plus 8, 8 plus 8, 16 microfarad. 16 microfarad. 16 microfarad is the answer. From the options, option A is the correct answer. Okay, next question. The value of current in the section circuit is shown below. Okay, current, where is I? Here, I value, we have to find I here. Okay, in this branch. Okay, we have to apply KCL. What is KCL? Incoming current is equal to outgoing currents. Apply KCL at this node. Okay, incoming current is 2 amperes, here 1 ampere, 2 plus 1, 3 amperes will leave from here. Okay, from 3 amperes in this branch 1.3 amperes, remaining 1.3, remaining 3 minus 1.3, 1.7 amperes. Okay, in this branch 1.7 amperes is leaving. From the options, option D is the correct answer. Okay, next question. A capacitor stores 1.3 coulombs of charge at 2 volts. Its capacitance will be, okay, we know that Q is equal to CV. What is the value of Q? Q is equal to 0.3 given, 0.3. C we have to find. Voltage, what is voltage? 2 volts. Okay, 2 1 jam to 0.15. Okay, C is equal to 0.15 farad, 0.15 farad. Okay, from the options, option A is the correct answer. Okay, next question. A source of voltage V maintains a current of I in a circuit. The energy supplied by the current by the source in time t is, okay, energy, we have to find energy. V is given and current I is given. Okay, energy, what is the formula of energy? Energy is equal to power into time. Energy is equal to power into time. Okay, what is power? Power is equal to voltage into current, voltage into current into time is t. Okay, energy is equal to VIT. From the options, option B is the correct answer. Okay, next question. If 36 joules of work is done in moving a charge Q across 8 volts, find the Q. Okay, We know that voltage is equal to work by charge. Voltage is equal to work done by charge. Okay, voltage is given, voltage is 8 volts and work is 36 joules. Okay, Q is equal to 36 by 8. 8 1 ja 8 4 ja 32, 4 8 5 ja 40. Okay, from the options, option D is the correct answer. Okay, next question. If 90 joules of work is done in moving a charge of 2000 coulombs across V volts, find V. Okay, we know that work by charge. Okay, we have to find voltage. Work is given, work is 90 joules and charge is 2000. Okay, 0 will cancel, 200 1 ja 200, 0.045 will come. Okay, voltage is equal to 0.045 volts. Okay, from the options, option C is the correct answer. Okay, next question. Find the potential difference across a resistance of 3.6 kilo ohms through which 2.5 milliamperes current is flowing. Okay, we have to find potential difference. Okay, resistance is given, the value of resistance is 3.6 kilo ohms and current flowing through this resistor is 2.5 milliamperes. Okay, we have to find voltage. Okay, we know that Ohm's law, voltage is equal to current into resistance. Okay, what is current? 2.5 milliamperes. 2.5 into 10 power minus 3, milli means minus 3. Okay, resistance is 3.6 kilojoules. 3.6 into 10 power 3. Okay, 10 power 3 and 10 power minus 3 will cancel. 25 by 10. 2.5 is equal to 25 by 10 and 3.6. 36 by 10. Okay, 5 5 ja 5 2 ja. Okay, 2 1 ja 2 18 ja. Okay, 18 into 5 90. 90 by 10 is equal to 9 volts. Okay, from the options, option B is the correct answer. Okay, next question. Two resistors of 2 ohm and 6 ohm connected in series. This combination is connected to 12 volts battery. Find the power supplied by the battery. Okay, two resistors are connected in series. One resistor is 2 ohms and one more resistor is 6 ohms. Okay, voltage applied across this combination of resistors is 12 volts. Okay, we have to find power. Power is equal to V square by R equivalent. Okay, V is 12 volts, 12 square is equal to 144 by R equivalent. R equivalent is equal to 2 plus 6, 8. Okay, 8 1 ja 8. Okay, 64, 8 8 ja 64. Okay, from the options, power is equal to 18 watts. From the options, option B is the correct answer. Okay, next question. The resistance of uniform metallic conductor is inversely proportional to its resistivity, directly proportional to its area, or inversely proportional to its area, or inversely proportional to its length. Okay, we know that R is equal to rho L by A. R is equal to rho L by A. Okay, R is directly proportional to its resistivity and R is directly proportional to its length and R is inversely proportional to its area. Okay, we can check options one by one. Inversely proportional to its resistivity, right? It is directly proportional to its resistivity. Option A is wrong. Okay, directly proportional to its area. It is R is inversely proportional to its area. Option B is also wrong. Okay, resistance is inversely proportional to its area. Okay, right, R is inversely proportional to its area. Okay, option C is the correct answer. Okay, next question. The resistance of the conductor when its temperature increases. Okay, temperature increases మన రెసిస్టెన్స్ ఆఫ్ ది కండక్టర్ అనేది ఏమవుతుంది. ఓకే, మనకి 3 types ఆఫ్ మెటల్స్ ఉంటాయి. ఒకటి కండక్టర్, ఇంకోటి సెమీ కండక్టర్, అండ్ థర్డ్ వన్ ఈజ్ ఇన్సులేటర్. ఓకే, వన్ కండక్టర్, సెకండ్ వన్ ఈజ్ సెమీ కండక్టర్, థర్డ్ వన్ ఈజ్ ఇన్సులేటర్. ఇన్సులేటర్. ఓకే, మన కండక్టర్స్ అనేవి పాజిటివ్ టెంపరేచర్ కోఎఫిషియంట్ మెటల్స్. పాజిటివ్ టెంపరేచర్ కోఎఫిషియంట్ మెటల్స్. ఓకే, మనకు సెమీ కండక్టర్స్ అండ్ ఇన్సులేటర్స్ అనేవి నెగిటివ్ టెంపరేచర్ కోఎఫిషియంట్. సెమీ కండక్టర్స్ అండ్ ఇన్సులేటర్స్ ఈజ్ హ్యావింగ్ నెగిటివ్ టెంపరేచర్ కోఎఫిషియంట్. నెగిటివ్ టెంపరేచర్ కోఎఫిషియంట్. ఓకే, అసలు పాజిటివ్ టెంపరేచర్ కోఎఫిషియంట్ అంటే ఏంటి, నెగిటివ్ టెంపరేచర్ కోఎఫిషియంట్ అంటే ఏంటి? పాజిటివ్ టెంపరేచర్ కోఎఫిషియంట్ అంటే ఇఫ్ టెంపరేచర్ ఇంక్రీజెస్ ద రెసిస్టెన్స్ ఆల్సో ఇంక్రీజెస్. ఓకే, if temperature increases resistance also increases. నెగిటివ్ టెంపరేచర్ కోఎఫిషియంట్లో మన టెంపరేచర్ ఇంక్రీజ్ చేసామనుకోండి రెసిస్టెన్స్ డిక్రీజ్ అవుతుంది. ఓకే, ఓకే, మనకి రెసిస్టెన్స్ ఆఫ్ ఏ కండక్టర్ ఈజ్ ఏ పాజిటివ్ టెంపరేచర్ కోఎఫిషియంట్ మెటల్. ఓకే, ఇఫ్ టెంపరేచర్ ఈజ్ ఇంక్రీజ్డ్ ద రెసిస్టెన్స్ ఆల్సో ఇంక్రీజెస్. ఫ్రమ్ ద ఆప్షన్స్ ఆప్షన్ డి ఈజ్ ద కరెక్ట్ ఆన్సర్. ఓకే, నెక్స్ట్ క్వశ్చన్. ద థర్మిస్టర్ హ్యాస్ డాష్ టెంపరేచర్ కోఎఫిషియంట్ ఆఫ్ రెసిస్టెన్స్. థర్మిస్టర్. ఓకే, థర్మిస్టర్ మనకు థర్మిస్టర్ అనేది వన్ ఆఫ్ ది సెమీ కండక్టర్ అనేది నెగిటివ్ టెంపరేచర్ కోఎఫిషియంట్. సెమీ కండక్టర్ నెగిటివ్ టెంపరేచర్ కోఎఫిషియంట్ అయినప్పుడు మన థర్మిస్టర్ కూడా నెగిటివ్ టెంపరేచర్ కోఎఫిషియంట్, ఎందుకంటే థర్మిస్టర్ అనేది వన్ ఆఫ్ ది సెమీ కండక్టర్. ఓకే, థర్మిస్టర్ ఈజ్ one of the negative temperature coefficient of resistance. Thermistor is having negative temperature coefficient of resistance. Okay.